Actually, I don't have them to screen share, I think.
You were already screen sharing?
Let me see.
At least through Zoom, you were sharing your screen.
Yeah. Let's check that everything's working, and I think we should be good. Yeah, I think we are live, and many people already have joined. So we have like 43 people right now watching. So hi everyone, welcome to our next FHIR meetup. So let's start. Today we have our FHIR meetup about security, and just one announcement before I pass everything to Josh and Nikolai. So based on our previous meetup experience, like 3 hours, many presentations, we decided to change the format a little bit. So we plan to try one presentation every other week. So whoever wants to present something interesting about FHIR, about their work with FHIR, please reach out to Health Dev meetup organizers, and we'll try to host you. So again, plan to have one presentation and QA every other week. And today's meetup, Nikolai and Josh, please.
Great. Let me check if my audio is working. Yes, cool. Awesome. Well, we've got quite a cast of characters and participants for this call, including the sort of group of panelists here on Zoom. And I see almost 50 people are watching on YouTube. So thank you everyone for joining. This is sort of a miracle from my perspective of lightweight planning, but actually Pavel deserves all the credit because even the lightweight planning process involved a bunch of outreach and setting things up so that we could come together and have a set of conversations. What I am hoping we can do over the course of today's discussion is a little bit of just-in-time planning. So thank you already to those of you in the group here on Zoom who have proposed topics to talk about. Everybody picked a 15-minute time slot as what they requested, which I think is probably a little bit of an anchoring effect because I populated mine at 15 minutes and I feel like maybe people just followed suit, but we can adjust if certain topics would benefit from more time. But this is a link that we've also shared out on YouTube as well as on Zulip, so folks can come here and indicate which things they're maybe most interested in learning about or discussing. And I would encourage everyone who's listening to feel free to come here and add a topic to the list. We can sort of dynamically reorganize as we go. But otherwise, I was thinking we could jump in and I might share a few slides that just give a sense of how I think about some of the challenges in authorization for FHIR, laying out like one piece of the landscape, but you'll get other perspectives from our other panelists. And by no means do I think I have like the one true view here. I just wanted to sort of give a sense of how I look at things. Before we do that, before I sort of jump in and share some slides and do this kind of overview, any comments or questions as we kick things off?
I think it would be nice right after the topic have a discussion. So the idea we will have a short presentations and then a lot of discussion. So that's the main idea.
Good. Well, I'll try to model that with my overview. I blocked off a 15-minute slot or requested a 15-minute slot, but I'll try to talk for less than 10 and then leave at least 5 to talk through. And obviously, we don't need to keep to a strict schedule here. We've got a good chunk of time, but we just wanted to have at least a guess. So let me see if I can successfully share my screen. Each time I've done this using the Linux client, there's been something new and different to learn. Okay, this time, all right. Can folks see my security policies generic flow picture? Yeah, awesome. So this is sort of a picture that I made up that describes one kind of take on how information flows through a request into a FHIR data service. And as you can see, the parts on the left and the right, the request and the response, represent sort of the way that a client might connect to a server, or a data requester might connect to a data system. And in the middle, there's some sort of computation job, which is maybe kind of miraculous, that takes details from what's being requested, and it takes some data from a FHIR data system of some kind. And then what I've described in this box along the bottom of the diagram as kind of authorization context. Where did that come from? Who created it? What does it say? Was this something that was requested and negotiated? Was it pre-specified? All of those are very interesting and important details about where this authorization context originated from. And then there's some interesting questions about how it's represented. So I wanted to highlight two main points with this diagram, or two questions that I'm hoping we'll be able to get into some detail on over the course of today's discussions. First of all, question one, I drew a box in the middle that says a miracle occurs, but like in more detail, what is the nature of this miracle that's supposed to happen so that we get out the data we're supposed to have? So I'm hoping that we can really delve into that. And then the second question is, for that bar across the bottom with my authorization context, like what is the language in which these policies or this authorization context is written? I know that's a topic that folks have spent a lot of time thinking about. So I want to go into a couple more levels of detail about what is that box in the middle where I say a miracle occurs here. And actually, I think there might be many different kinds of miracles that we need under different circumstances. So one kind of circumstance or constraint that we care about a lot is timing. So if you're dealing with something that's running on the order of 10 million milliseconds, like a data bulk export operation where I'm going to give you a bunch of files to download, that's a very different paradigm than if you're running a REST API server that needs to respond in sort of near real time on the order of 1,000 milliseconds and give you back a bundle of just the right data. And so pragmatically, the processing options that are available to us at these different timescales might look quite different. Maybe you can do more sophisticated things if you've got more time, or maybe you need to be more clever about it. And I want to say, from the perspective of kind of standards development, it's really tempting not to worry about these kinds of constraints. If we get our standards right, actually, the standards might not deal with this level of detail at all. But we also need to make sure that we're informed by the constraints of real world systems under the hood. So my sort of proposed focus for today, and everybody is more than welcome to bring their own focus to the conversation, but the place where I've been thinking the hardest has been, what are the solutions that can work for these near real-time scenarios, like a FHIR REST API call? And of course, if we can develop things that work quickly, we can also use them when we've got more time, when we're doing something like a bulk data export. The things, it doesn't work in the other direction. If I'm developing something that needs a lot of time, it's not going to be applicable to the REST API kind of real-time API calls. So if I expand that diagram and talk a little bit about what is the nature of that miracle that happens in the middle, this is one way to think about it. And again, I don't know that we need to standardize at this level, but it's useful to have a conceptual model so that we know our standards actually fit to some deeper level implementation guidance. So one way to think about it is a system that's going to respond to one of these requests maybe is dealing in a few stages. There's an early stage that happens where the system is, I've labeled it here as pre-analysis, but it's looking at the request and trying to see what it can decide just based on the shape of the request itself. There's this sort of interesting piece in the middle where maybe a FHIR resource server is hitting its data store. Maybe that's a database somewhere or any kind of data store really, and fetching the relevant subsets of the data. And this is something where performance really mattered a lot. Do you have some kind of indexing strategy? What are the things that are easy to pull out or hard to pull out? How much of that can you put into the database? And then maybe there's a set of post-processing steps. So like just before you return the results to the client, maybe there are some things that you want to do in order to either check that the data you're returning looks right, or maybe even make some kinds of transformations. And when we think about these steps in architecture, there's different kinds of processes or capabilities that make sense at these different points. So I'll share a couple of thoughts on each of these and then open up for sort of discussion. So the first one was that pre-analysis box. Where the interesting opportunity here is to say, well, I know your query and I know your authorization context. How much can I get done with just that information? Can I just decide, yep, your query looks good, I'm going to approve it, or no, your query looks bad, I'm going to reject it, without having to touch my database at all, but just looking at the details of what you're allowed to ask for and what you have asked for. So that the simplest way to reduce this down is to say, I've got some kind of policy function that looks at your query, and it looks at your authorization context, and it tries to make a sort of true-false decision, thumbs up or thumbs down. And so there's some things that you can do really effectively here with just a little bit of authorization context and a little bit of policy. So maybe I want to define like this JSON example, or this query example at the bottom here that says, I'm only allowed to write a query if it matches one of these two lines. So the first one says, find me vital signs observations, where the patient has been specified in the query to match the patient in context, and the security tag of either U or L or M or N is present. So one of those four, which is to say not sensitive results. Or you could do something similar for medication requests to say, I want to get these prescriptions. And I've got a bug in my slide here. I shouldn't be talking about a category of vital signs on my med request. So you can just pretend that parameter's not there. And so maybe you just list all the queries that are allowed. And then you can easily say thumbs up or thumbs down every time a query comes in. And if it's thumbs up, you just pass it along to the FHIR server and run it as normal. So the really nice thing about that model is it's very lightweight for a server to support. You could even do this as a gateway in front of your FHIR server rather than in the code base for your FHIR server itself. And it makes all the queries explicit for a client. You know when you're sending along one of these queries, either you've got it right because it matches your policy, or you need to tweak it so that it fits within the bounds of that policy. So those are both advantages. I put little plus signs next to them in the list here. But there are also some real disadvantages or limitations here. So there are some very simple things that it's not obvious how to address with just this kind of pre-analysis. So maybe you've got a request coming in for a specific observation. Do you permit that request or not? It really depends on the data inside of that observation. You have to know what observation 1, 2, 3 is before you can really figure this out. Or maybe you've got a query that's like, find me a patient with a certain name in the database. And do you reject that because that query might touch patients you're not allowed to see? Or do you somehow sort of scope it down so you interpret it more like, find me the patients with this name that I'm allowed to see? Or do you go back to the client and say, no, you got to make this more specific. You got to prove to me that your query fits within the bounds of what you're authorized to do. And that can be possible, but it can also be pretty contorted, maybe even to the point where it starts to break. But if I think about how to do that, how would you take a query like find me all patients named Eve and turn it into something that's maybe allowed by this policy? It would be something like what I wrote here, where you look for patients named Eve that are members of a group where my practitioner, who's the user in context here, is a member of that organization. And the FHIR API sort of maybe lets you put together these kinds of reverse chaining to say, I'm only searching for patients I'm allowed to see, and pack all of that into the query. But it starts to get pretty difficult for client developers to understand, and pretty difficult for servers to be able to actually implement all these joins, as it were, in real time to be able to evaluate this. So I look at that and I say, maybe it's theoretically possible, but it doesn't seem super practical. Really, if you want to get into these fine-grained details of pulling out just the right data to fit a query, you can imagine pushing that query deeper into the database. And the ideal state here is easy enough to say, which is how can you create a sort of server endpoint that simulates a FHIR server base URL that has all the full flexibility of the FHIR API, but hides any resources you're not allowed to see. So basically, give me the abstraction of a server that just shows me what I'm allowed to see. And there's some pieces of the FHIR API that are maybe helpful in describing that context. We have search parameters that we already know how to index and put those indexes into our databases for a lot of the generic FHIR servers. We have things like compartment definitions that can be indexed, maybe graph definitions, if I'm thinking about sort of different parts of the FHIR spec that have a language like this. And maybe there's a place for things like defining groups and roles. And we have a FHIR resource for group, although it's not really scoped to do security groups, but maybe there's something there. Maybe we should be defining specific roles as well in the FHIR context. So the nice thing about pushing your queries like this into the database is maybe it performs better because you can take advantage of the capabilities in your database. Maybe you can ensure some kinds of correctness by actually, again, taking advantage of core capabilities like row level permissions. But it's not actually clear how to make this feasible as the complexity of your policies grows, as you write sort of arbitrarily interesting policy statements. So some things are easy, like maybe allow access to everything within the compartment of patient 123. Maybe that's straightforward because servers already know how to index on those compartments, or maybe hiding anything with certain security tags because servers already index on tags. But there's also policies that are not at all clear how to implement here. So, if I want to just share patients that user 123 is authorized to see, well, FHIR doesn't necessarily have a concept of user 123. So where should that information even live? Should there be a place in FHIR for that sort of policy about patient 123 or about user 123's permissions? Does that live outside of the FHIR server in some sort of service that you can call, like an identity management service? Those are sort of open questions. It can also be very hard to sort of do data hiding at a fine granularity, like based on the specific observation codes that are found, just because data might not be indexed in a way to make that perform well. So those are just a few thoughts about what you can push into the database. And then finally, I'll end with this quick note about the things that you can do in the third step, that sort of post-processing step. And there's some things this is really great for. So like sanity checking to make sure that I'm not about to return something with a sensitive tag when the user's not authorized. I can put those checks in at this point in the process and give myself one more layer in my defense in depth to make sure that I'm not leaking something I shouldn't. And there's certain kinds of transformations that work really well here. So these are what I think of as one-to-one transformations or sort of one-to-zero transformations, where I'm looking at the elements of a resource and I'm maybe redacting some, or I'm blurring some of them, doing some kinds of de-identification steps. Those work really well. But there's a class of things that don't work really well as post-processing steps. And those are sort of many-to-one transformations where I might need 1,000 resources. And if I'm trying to apply my filtering down in this post-processing step, only 1 out of 1,000 are going to be good. I have to sort of keep going back to my database to get more results because I don't know until very late that I haven't built up enough yet to return to the client. So anything that sort of has that flavor of many-to-one doesn't necessarily make sense in this final bucket. So that's the sum total of what I wanted to share today. Nothing really in the space of solutions, but just sort of a landscape of what I think of as some of the key sort of questions and assumptions that we might want to think about as we design. And we can take maybe a few minutes if there's reactions, thoughts, concerns, complaints. I'd love to dig into this before we move on.
Yeah, Josh, if I can start.
Please.
It seems that when you talked about authorization, you kind of talked about access control as well. But it's worth clarifying the language because historically we've sort of said authorization is an OAuth scope related thing, whereas access control is to do with the user's underlying rights and privileges.
Yes, I am definitely blurring those lines. And it's somewhat intentional because at the end of the day, like if we're in the job of building a FHIR server that's going to meet production workload requirements, we need to solve all those problems somewhere. I don't have a very strong stance on which of those things we want to solve in FHIR specs versus elsewhere. But I do know that we need to solve that whole set of problems. And that includes things like what is a given user allowed to do? And it also includes the sort of delegation piece, which has been our focus in SMART, which is given that I'm allowed to do X, how can I delegate those capabilities to another party like an app?
So thank you. One more language clarification. We in this case. Who's we? Because the FHIR project itself has pretty much every year decided that we're not taking on the security management problem.
Yeah, so I don't know, Grahame, is the short answer. I would be very pleased if the answer involved like some of the organizations and companies on this call who wanted to get together and agree on a set of rules that sort of worked well for FHIR servers in the cloud. That could be like one subdomain of this problem. But I think that the easy answer, the trivial answer is the broadest consensus group that we can meaningfully get to solve a good chunk of these problems.
Okay, so I'll finish one more thing before I finish. We've traditionally said we won't take on the security problem for 2 reasons. First of all, user rights management of the users themselves is, we think of someone else's domain, and there's actually SCIM for a RESTful API for managing users and groups and passwords and so forth. But we haven't taken on the deeper problem of healthcare access control because there hasn't been a group of parties who've come to HL7 and said, we would like to see this made interoperable and we're prepared to work towards that. There's been some discussion about that and maybe David wants to add to that, but there hasn't been consensus that we want to go there.
Yeah, so David, I do want to hear your perspective on this. My quick response, Grahame, there is I don't know if, I'm not proposing that we go and like start a project in HL7. I think we've got a great set of participants in this meetup who are trying to solve these problems in some way. And even if all we're doing is sharing practices that work, like that's a great start. If we can codify stuff informally, great. And if there are opportunities to standardize, then we'll look at those too. David,
Sure.
I cut you off.
Before David, I just wanted to scope out the discussion. I would be prepared to revisit some of those decisions if there's a stakeholder drive to do that. I just wanted to sort of lay the land on that, and I'm done.
May I give some comments to Grahame comments? So I understand that the access control domain is kind of variable, but probably during this discussion, we will get some requirements or new ideas which can be implemented in a FHIR standard and help to do the better access control.
You know, I don't know if FHIR access control is the best way to do that. Right now, OAuth and, you know, various aspects of OAuth have been really working well. And in the large scales I've been working with lately, trying to bring that into FHIR would add a layer of complexity. Yes, you could put in simple role-based or attribute-based access control into a FHIR server, but you've already got that. And in most cases that I've been dealing with, we're looking at straight purpose of use, where the user may be coming in, you've never heard of this person, you have no preset role for them. You have to accept their purpose of use, being that treatment or, you know, research or organizational, accept their credentials because either they come in with their own credentials through a cert, or they come in with a network cert like Care Qualities or Commonwealth certs there, who say you can trust these people. The minute you try to internalize that into the FHIR server means you start having to do certificate, you know, validation, all kinds of things. I mean, it's fine if you can do that internal to a hospital or a single organization. The minute you try to bring that out, you're going to add layer complexity, because you have to then go beyond just, hey, it's Bob Smith, I am clinician with this organization, to I can prove I'm Bob Smith, and therefore you should accept my credentials and my purpose of use of treatment and give me what I want. And I think that's, trying to bring that into a FHIR server really is going to add a layer of complexity to FHIR that I think OAuth handles quite well.
Yeah, let me clarify that we understand that the access control is out of the scope of FHIR specification, but it's a deeply related problem, because if we want to do the fine-grained access control, we go into the informational model. And that's why we're discussing this. We completely understand that it should not force some authorization standard in FHIR. But this is deeply related topic, and I think it's good to discuss it together and see maybe FHIR can make a couple of steps forward to simplify the access control. Because from pragmatic point of view, all of clients who really, all the users who really start using FHIR have this concern: how we will protect our servers, how we protect our information, and there is no answer for this from the FHIR community. I mean, from the FHIR spec, but we can give answers from the FHIR community, and that's the main motivation of this discussion.
Could I jump in here for a moment? Yeah. So this is, you know, the underlying question is, of course, about fine-grained access control. But if you are trying to define fine-grained access control, you have to understand what the grains are. And that's really where this discussion within the FHIR space starts to really pay off, because it's not enough for a security protocol to give you a way to describe how you access stuff. You have to know what it is you're describing, and importantly, how to apply that in a consistent and predictable way. Because if I just give you a scope and that means something slightly different, if I call Graham's server versus Josh's server, then we could be looking at a massive privacy violation here. If you suddenly get to decide what sensitive means, just to pick a ridiculous straw man example, And when you really dig down into it, Josh's point towards the beginning is absolutely spot on, in that all of these different layers of applying security that we like to think about, they all kind of end up getting mushed together in the actual application, because fundamentally you've got an API and it's getting a request. And Josh, if you could actually pull up that big diagram again. The one with all the bits. Yeah, the miracle. Sure. This is great. The miracle there is that your service knows which response to give to which request. That's all that security is. It's a way of describing and understanding which response you give to which request. Do I give you the data, or do I give you an error? Do I give you all of the data that I have, or some of the data? Do I modify it in transit? All of those operations in the different boxes that Josh had are coming down to answering that question. So while it is useful in modeling our systems architectures to think of things in terms of these different layers of, this is access control and it's identity based, and this is authorization and it's resource based and stuff like that. Ultimately, it all comes down to answering this question of, what response do I give to which request?
So I have a feeling we could extend this conversation for a long time, but actually I would love to give Justin the opportunity to take that comment as a transition into sharing some thoughts on the OAuth XYZ protocol. If there's a couple last comments that folks want to get in before we move on, I'll open up the floor. All right, Justin, are you prepared?
Maybe
actually schedule you into a time slot.
Maybe can I make my presentation right after your, because I think I have some answers, at least some examples what you asked it, and it's like a logical.
Great, sure. So I'm going to move Justin's presentation to the third slot. Nikolai will switch over to you. I'm going to stop screen sharing, but everybody feel free to add notes or reorder stuff in the document as we go.
Okay. So.
Yep, that's fine with me, by the way. Go ahead.
Thanks.
Thank you, Justin. And can I share my screen, Josh?
Yeah, I guess I have to hit stop first.
Yeah, you have to unshare before.
I have unshared.
Okay. Can you see my Emacs?
Yes.
Okay. So I just want to tell you the story how we implemented access control in Aidbox. It's a FHIR server. We did it like 2 years ago, and it's used in many systems. So probably this talk will contain some answers, some decisions what we did about answers Josh asked. So initially it's implemented as a simple middleware in a FHIR server, which can be pre-configured with a custom resource, which we call access policy. So as well, in our FHIR server, we have the bunch of other custom resources like the scheme user, the roles, the house client. And here, for example, the user resource, which can be extended with a link to the patient or practitioner. And another step, so we model the request as a document or as a resource. So we see that each request we turn into the, let's say, JSON document. We're trying to parse as much as possible. So we're parsing the parameters of query string, we're parsing the path parameters, and we enrich this request document with a context information, like if there's a user in session, so we add the user. If there's a REST client, even if it's JOT, we just add the claims from the JOT, and the body is present here. So then the access policy, in our case, it's just a function which getting request and returns the result, is it allowed or deny? And what's important, I will tell it later, so it can explain why it decided this way, because it's sometimes it's important how practically you work with these policies. So actually, so we have like a polymorphic function while which getting the policy resource and the request, and we evaluate it in a chain. So, for example, the access policy resource, we have multiple engines which are extendable, so different languages can be applied. The access policy can be linked to the REST operation, to the user, to the client, or to the role by name. And then we evaluate all the policies on the server in a specific order. We're starting from policies which are attached to this REST operation, which are called. Then we see if the user or client has attached policies and evaluate these policies. If user has roles, then we can evaluate the role policies. And then we fall back to the global policies. If one of the policies say it's okay, then we return the response. So we have different implementation. What we try to achieve, we try to make the policy as declarative as possible, so the users can configure the server declaratively by creating this just access policy resource. So we have different engines. The very simple engine, it's a JSON schema, and it works like this. So you write the JSON schema for this request document. If request document conforms to this JSON schema, then we allow user to access this endpoint. So for example, you can write the simple policy that the authorized user can access anything, can send the get request to the patient, something like this. So we have another DSL, which is like a sugar for a JSON schema. We call it macho. It's like a pattern matching stuff. And what's important here, so you in this, you can use this the same in JSON schema. So you can match with the data from the request context. Like you can say that this encounter. So we allow to get the and post to encounter only if and we enforce with the policy that should be parameter practitioner, which is equal to the user data practitioner ID, something like this. So, and this is examples of simple access policies, which need only the request to make decision. But we have a more advanced policy, which is called SQL engine for the access policies. And the SQL engine, you can run like a templated SQL on FHIR, let's say, on the server, and you can make decision based on data in your database. And we have like a closure policy because it's written in closure. So another important point that when users start writing these access policies, they need to debug these policies and introspect these policies. That's why the policy should not only say yes or no, but in some explain mode, it should explain why it said yes or why it said no. As well, you should be able to turn on the audit trails to see sometimes even per request to see how this access control behaves. So for example, we have a custom operation where you can simulate the query and see the result with explanation what access policy and make decision and why. So the few tricks we use in real systems. So we enforce by policy, for example, some search parameters that allow us to build a policy where for example, practitioner can only see encounters which belongs to this practitioner, for example. And this works with this FHIR search API, but what we see that people starting using this idea, and probably we need the elements parameter for most of REST API, for the read operation, and even maybe for the write and patch or update operation. And if we will have this elements parameter for the REST API, then we can use the same trick like enforce by policy specific elements. And we did extension for elements parameter. First of all, we allow to specify the nested elements for the more fine-grained control over the elements which are returned by the search API. As well, we allow to specify elements of the included elements, because with the search API, we can get included resources, reference resources. And I don't know, probably we need to extend the elements language even more, maybe use something like FHIR pass to mask some another elements, or even maybe apply some transformation. So maybe it's not element, but let's say transformation parameter, and then set which kind of transformation should be applied to the resources to maybe hide some sensitive information. Another case from the field that users start using, we have a dynamic compartments, and we implemented the standard compartments, and users start using compartments a lot to simplify the access policy. So they create the compartments, and then they can write much more simpler access policy when they use compartments, because they like assure that everything will go okay. And we even have a request to write into compartments, but this is different BC. So because and I think the idea of write to compartments means that that operation will inject some proper references and stuff like this. So so few design points when I was thinking about the access control. The first of all, I see a lot of people like do not follow the REST idempotence. I don't know how to say this word properly. So I still think that the same URI should return the same resource, and all the parameters, if the response should be different, should be explicit in a URI, maybe in a path, maybe in a search parameters. Otherwise, we see a lot of problems. So do not change the response implicitly. Do not inject some logic based on the user session, and because we go against the rest, and we will have to pay for that. Another idea that, as we see with compartments definition, that like a Pokayoki stuff. So sometimes it's better to design the API that way that you could not make mistake, instead of checking everything. So, and we can like go further with compartments and just design the API to be friendly to access control. And another real problem that when policy is getting more and more complicated, you can get real performance hit for that, because the simple policies are based on requests, and they are working quite fast. But when we go to the policies which are querying data in database or even calling external services, so the performance can be a real problem, because the cost of the checking access can be even bigger than just getting the data. And here we may probably have to think about some caching strategies, or maybe say that this policy or this decision, access control decision, can be cached some time to leave, I don't know. So, and I would like to end with the idea which I call the API construction, and we can think it like a compartments on steroids. And the idea that on a FHIR server, we can define the REST API and enforce some implicit rules, like implicit search parameters, allowed parameters, some transformation, and then we will still follow the REST principles. So for example, this is just like a pseudocode. So we can say that we want to define the observation search, FHIR search operation under specific compartment, and we enforce that the patient will be taken from the path parameter and injected into the search, and we enforce some non-sensitive security labels. Then we can apply some transformation like elements. This is pseudo FHIR path, that we have to mask some results, some elements on the resource. We can list search parameters which are allowed to use, and we can even list like includes which can be used in these queries. And the same can be done for example, for the write operation. We can say that we are injecting some implicit elements when we creating the resource, or when we patching resource, we can provide like a white list of elements which some user can patch. For example, in this case, a nurse only can change the status and encounter, and we can create a special endpoint for the nurse which only allows to change the status, and probably set it to specific values. Okay, that's everything.
And Nikolai, on this last section here, you think it says custom operations, but do you think that we can generalize, create some generalized operations that would become a standard for doing these access control requests?
Probably yes. So my idea that the operation in FHIR is underestimated. And for example, if we have generic operation like FHIR search, it can be pre-configured like a post-coordinated, I don't know, after that, and then you can create the API. So for me, I think if we will put attention to the FHIR operation as a resource and ability to configure it and create the specialized API, that would be nice. But here we're looking from the pragmatic point of view, because we are backend and people building the application, and they sometimes don't care about the standard. They just want to make it work and make it work securely. So if it helps to bring something in a FHIR specification, I would be happy. Okay. No questions, so can I unshare my screen?
Yeah, and just so next we're going to transition to Justin, and please do go in and add your name next to the presentations you're particularly interested in. I'm going to sort by the number of interested parties that we've got for these presentations, and we'll use that as a rough guide on order. So Justin, you're up next.
Okay, just give me a moment to get this set up.
Absolutely.
All right. There we go. All right, hopefully that is showing my slides in presentation mode. Does that look about right?
Perfect.
Good to me.
Okay, awesome. All right, everybody. I am not very active in the FHIR community. I will start by saying that. I do a lot. My name is Justin Richer. I'm an independent consultant based out of Boston, and I do a fair amount of work in the security space. And Josh Mandel and I have actually worked on a handful of different things over the years. And I've been asked today to come talk about a new project that I'm working on that is called XYZ. And XYZ is a project. Let's see. Here we go. PowerPoint was acting up. It's a project that's designed to look beyond what OAuth2 is capable of and what the future might look like. And this has been in progress for about a year and a half or so. We have implementations in Java and Node.js, and they connect to each other. Somebody's working on a Rust implementation right now as well. There's a handful of these floating around out there. The details on the protocol, including links to both detailed presentations and some specification text, is at the website OAuth.xyz. And in case you were wondering, the website name actually came before the name of the project because I'm really bad at naming things. So that's why the project is named XYZ. It's a terrible name, but here we are. The important thing about this right now in its current state is that this is serving as an input into a brand new working group in the IETF. So XYZ started as an independent project, but I felt it was important that it not just be my ideas, that this come into the standard space to build a new generation of security protocols. And that working group has just gone through a very protracted bike shedding exercise, and we are now named GNAP. And GNAP stands for the Grant Negotiation Authorization Protocol. And you can find information about that and join that discussion in the IETF at the mailing list txauth@ietf.org. Now, one of the most important things to realize about the XYZ project, there's two things here. One, it is only one of the inputs that is going to go into the GNAP working group. So XYZ is not the end state of GNAP. GNAP's going to look a bit different from XYZ. How different? We don't know yet. We've got a long ways to go. But I'm going to be talking about XYZ as it stands today. The other important thing about XYZ is to realize through all of this that it is not OAuth2 based. It is not an extension to OAuth2. It is not built on it, and it is not compatible with it. There's a whole litany of reasons why not, and I've given presentations about the ways in which OAuth has been broken over the years, and the way it's being stretched into different use cases. But most importantly, we've just learned a lot about what works and what doesn't in the last decade of using OAuth2 to do basically every kind of security flavored thing on the internet. So without further ado, I'm going to get into a very, very quick overview of how the XYZ protocol works. It's my hope that the GNAP protocol, when it is defined, will share a lot of these attributes as well, because I think they're valuable. First off, in OAuth2, you guys will know that everything starts with the client. When you've got a user involved, everything starts with the client redirecting the user in a web browser over to another server and kicking things off. There are a lot of problems with that from a security and privacy perspective. So in XYZ, we use the intent registration pattern. And what that means is that the client talks to the authorization server directly first and starts up what I call in XYZ a transaction. And it basically says a whole bunch of information about what it is and what it wants to the AS. And each of these sections gives a different aspect about this request. Now, all of this is happening in the back channel. So this is not going through a browser. This is a direct HTTP call. First, and probably most directly apropos to this group, is the resources section. This is a description of what I want. And one of the things that I wanted to address with XYZ is the fact that in OAuth scope, as a single string, it's kind of a zero-dimensional data structure that everybody tries to fit everything into. And, to pick on Josh again, I remember a project that we did many years ago, Blue Button Plus REST or something like that, where we had structured OAuth scopes that you would have to parse, and they had colons and sub pieces and all of this other stuff. And quite frankly, it was kind of a mess, but we were using the tools that we had. With XYZ, what I wanted to be able to do was have an expressive multi-dimensional way to make access requests. So what you have here is an array of JSON objects, and each of those JSON objects has multiple orthogonal dimensions in it. The examples here are actions is the kind of thing that I want to do, locations is where I want to do it, and data types is the things that I want to do that thing to. But there's two really important things to this. One is that this is meant to be extensible. This is meant to be ultimately API specific. So FHIR, for example, probably has a number of other dimensions that we would want to add here. So sensitivity information, for example, and whether or not this is a break the glass type of scenario. We could have a flag for that. It's a JSON object, and so we could have all kinds of information about what exactly we want to access. The other thing I want to point out here is that this is an array of objects. And so when I am making a single request, I could be asking for a lot of different aspects to be brought back into my access token. Those could include patient identifiers, they could include record identifiers, they could include lots of different things, which would allow me to get, for example, write access to one aspect of a patient record, but read access to the rest. I now have a way that I can describe that in a way that is clear and unambiguous. Now, the next thing that the client needs to do is tell the server who it is, what software it is. And instead of using client IDs in XYZ, clients are identified by their keying material. And so in this case, the client is presenting its public key. However, the client isn't just presenting its public key, it has to prove possession of the associated private key every request that it makes. And there's going to be a bunch of different ways that you can do this, either by signing the HTTP message or using mutual TLS or a number of other things. And this really needs to be flexible because different types of client applications have different types of deployment patterns, everywhere from ephemeral in-browser client instances to back-end MTLS protected enterprise data systems, and everything in between, and stuff that we haven't invented yet. Now, OpenID Connect adds ways on top of OAuth to get information about the user, and we wanted XYZ and ultimately Grahame to be able to ask for some simple user information, but we also want the client to be able to present information to the AS, because sometimes the client actually knows more about the current user than the AS does. And this becomes very important when we're talking about how the client can interact with the user, because the client software ultimately knows what it can do to get the user involved, whether redirecting to the server or presenting a typable user code or sending a message to an agent or any number of other things. We need to have a very, very flexible interaction mechanisms. And one of my sort of early light bulb moments when I started to work on XYZ was that this is ultimately kind of what all of OAuth's flows, all of its grant types kind of get at. They get down to how can I interact with the user or not? And what does that look like? And so what I decided to do is, instead of have a sort of a type-based system like the grants in OAuth2, the client says its capabilities. This is the list of individual elements of interaction that I can do. And whatever one of those that the AS supports or needs to use for this request, it can do so. And that can be pushing information, that can be redirecting, any number of things. The AS gets all of this information and perhaps other top-level request fields as well, because that is also intended to be extensible. And sometimes it's going to decide, okay, so the client's told me who the user is. I've already got their consent on record. I'm just going to give you an access token. We already see this in the OAuth world with the assertion-based flows and the client credentials-based flow when there is no user to interact. But that client is allowed to do this. The auth server can make this determination right there. Or it could decide, you know what, I do need to talk to the user, but the client has told me how it can do that. So in this example, the client said that I can redirect. The server says, okay, great. We're gonna let you bump this to the front channel. So I'm going to give you a URL to hand to the user to interact with. And the client's gonna send the user there in their browser. Now, this is gonna start to feel a little bit like the authorization endpoint in OAuth, but a key difference is that the client doesn't manipulate that URL at all. That URL is dynamically generated by the authorization server, and it represents this specific ongoing transaction, which means when the request comes in, the auth server looks up the transaction based on that incoming URL, where the client has already authenticated itself, where it has already specified all of that information about what it wants and how it, how it can do things. And so none of that needs to be pushed through the browser anymore. And this is a really, really, really important benefit of intent registration. Now, at this point, the interaction is pretty much what you would expect. The user can log in, authorize things, modify what's being asked for to what they really want, provide additional information, whatever. And then the auth server, very similarly to OAuth2, creates a reference, the equivalent of an authorization code, and some hash-based protection to tie all of the different legs together. I'm not going to go into all of the protocol details here tonight. And then all of that comes back to the client, which can now continue the transaction because it got a handle that allowed it to call the authorization server again and say, hey, I want to take the next step on this, and here's the information that proves that I am the piece of software that got the user back from the front end. Now, when making this request, the client is not presenting its public key, it's not presenting its scopes, it's not presenting anything, but it is still proving possession of its referenced keys in fact, the referenced keys that it presented in that first step, it has to prove that it still has access to them. And then eventually the access token comes back. Now, that last bit feels a lot like OAuth2, but there's a bit stronger flexibility there because of how we're modeling things. And we'll get back to that in just a little while. First, I want to talk about this construct known as a handle in XYZ. Now, a handle is a way to basically pass something by reference. So instead of passing the key information as a public key, like we looked at before, I can pass you a reference that the authorization server knows represents that specific key. Now, does this sound a little bit familiar for the OAuth2 developers? Well, it should sound a lot like me sending you a client ID and you looking up which key is associated with that and then making sure I'm using that key. Functionally, it's very, very similar, except that because this in XYZ is split out to just the key, we can actually vary the handle for the key with the handle for other parts of the software itself and the requests that it's making. So we're not tied into the strict sort of monolithic model that OAuth puts on clients and associates with clients IDs. Of course, the client, it still has to prove possession of the key even when it's being passed by reference. Skip over that part. And my apologies, I pulled this slide deck together this afternoon, so it's a little rough in spaces. There are also cases where the user has gone through a whole bunch of hoops and have proved that they are a specific user to the authorization server, and the authorization server trusts the client and says, you know what, the next time that you know that it's that same user coming back to me, send me this handle instead, and I'll know which user you're talking about. This is pulled from a concept of the user managed access protocol, but it's standing in for one of those request pieces where the client is able to push assertions and information about who the user is to the server. It's now pushing in a handle that represents who the user is. So it's a consistent data model across a lot of different things. And this consistency keeps going because remember those OAuth scopes? Well, for a lot of APIs, and I would say for things like FHIR, scope strings are really not a very good fit. But for a lot of other APIs, they work really well. They are simple. They are single strings that developers can just bang into the software and it'll just work. And you branch your policy based on these. Well, in XYZ, we make use of something called polymorphic JSON in our protocol design, which means that resources array, which was an array of objects, can also contain single strings. Except that these single strings are defined to unpack to a specific instantiation of one of those resource objects. And that's a really important kind of feature here, because sometimes a client needs to be able to get to these kinds of simple APIs and the complex APIs. So say I had a scope that said, yeah, give me all the patient information for the current end user for read access. And by the way, I also need a whole lot of other information about this one specific part of their medical record, right? I need write access into the X-ray images on this server, but give me read access to whatever else I can get, right? It lets us mix and match these things together. And speaking of mixing and matching, that whole point about interaction is that we can have different modes of interaction without doing completely different protocols, which is what I would argue happens in the OAuth2 space. If you've ever implemented the device flow versus the authorization code flow versus client credentials, they all work pretty differently when you get down to it. They share a lot of parts, but fundamentally they're different protocols. In XYZ, these all turn into different interaction methods so that the only place that they differ is where we get the user involved. So say we need to be able to, instead of sending the user to an arbitrary URL, we have to send them to a statically configured URL and have them type in an arbitrary typable code. This is the device flow. Or we give them something that's scannable. So this is now an arbitrary URL that the user can scan, but we don't have a way to get them back. And it's important in XYZ that we separate all of those different aspects of interaction so that the user isn't, so that the client isn't stuck trying to fit all of the things that it's capable of doing into one specific lane. We could, for example, say, all right, maybe if the user has a WebAuthn authenticator on their device, the server can come back and say, great, here's my origin, here's the challenge, sign this, and I will figure out which user it is. So that means I don't have to redirect the user. I can handle it all directly on the device now in a way that's secure, in a way that the user experience can be really, really good. And it fits what modern systems do. Because OAuth2 was built as a website-to-website protocol. And really quickly, identity, I know I'm a little bit over time, but for identity, I really think that there's a sweet spot where we can get some really simple identifiers back alongside the access token that just simply tell us who the user is, without having signed assertions, without having to do all of this extra Jose wrapping and stuff like that. If I'm trusting you to tell me what the access token is, I should trust you to tell me what the user ID is. And some other basic information. Now, you don't want to get the user's entire profile back like this, because you probably don't need it on every request anyway. Give me an identifier that I can work with, and we'll go from there. So access tokens can be bound in the same way that these requests to the resource server can go. Discovery in XYZ is largely eliminated because the client only needs one URL to kick everything off, and everything else, like those interaction mechanisms, like the signing mechanisms, all of that, all kind of happens in line. And finally, this does not exist in a world where OAuth2 just isn't there. So it's important that concepts in OAuth2 have a place to fit in the XYZ and ultimately the GNAP world. So if we have something that is like a client ID already in our application that people are registering for and giving to them, we've got a place where they can plug that into the protocol and it starts to make sense. Same with the scopes and ID tokens and all of this other stuff. There's places where it fits. So even though it doesn't necessarily look exactly the same, it's a different protocol, it's different tooling, there's places that you can plug things in. So it's not backwards compatible, but it does allow your legacy systems to be more forward-looking. So the discussion is happening at txauth@ietf.org, and the write-up of OAuth.xyz, the write-up of the XYZ project is at OAuth.xyz. Thank you.
Thank you, Justin.
If there aren't, I was waiting for questions for John. I noticed that my slot got moved down just a little. What I'm covering would have been really good follow-up with, from Josh's and Nikolai's presentation, but just wanted to point that out.
Yeah, I'm trying to keep the schedule sorted by the number of people who have voted. So now that one more person has filled in their name on your slot, I'm gonna move it up. Justin, thank you for the presentation. While others are thinking of questions, I have one which is sort of process heavy, which is to say, a lot of us have a lot invested in OAuth2. It's been a long road to get to the point where there's actually pretty broad support, and we understand the works pretty well. And then started figuring out what the workable surface area is. When you think about TXAuth beginning a standardization process through IETF, what do you look at as the time frame, between where we are today and when we get to sort of a proposed standard?
Honestly, I'm seeing it in terms of probably a couple of years worth of work out there, because there's a lot of different aspects to this that need to be discussed, need to be implemented, need to be tried out before we can figure out what really works. And also, keep in mind, OAuth2 is not going away. It's not going away anytime soon. And it really was not lightly that I stepped into the process of trying to start a new standard, right? Like practically my entire career these days is doing OAuth2 related stuff. So it would be crazy of me to try to come up with something that makes everybody stop doing OAuth2, right? But the thing is, people aren't going to stop doing OAuth2 because OAuth2 works for a lot of stuff. Where Gnap is really going to shine is at the places where OAuth doesn't work. So ephemeral clients, OAuth is really, really bad at that. And I'm not talking about just SPAs that can be kind of, pre-registered en masse. I'm talking about like truly ephemeral clients where you stand up a little Lambda function and it generates a key and does its thing and gets authorized and then goes away. There's a lot of stuff in that kind of space. There's a lot of stuff in the distributed identity kind of space where we're seeing people think about problems and think about interaction and communication in ways that we just haven't before, and ways in which the OAuth2's model and assumptions really don't work anymore. They really kind of fall apart. And so, yeah, it's going to be a while before Gnap is ready. That said, people are, XYZ has definitely scratched an itch that people have. So there are people that are already trying it out and building it or variations on the theme into their systems today. And for those people, they are at spaces where OAuth2 doesn't work. And so they need something else. But I think that we'll really see Gnap come into its own, I would guess a couple of years from now. And then, if all goes well, best case scenario, over the next 10 years, we'll really start to see it roll out and understand things, and we'll go from there. I will add, though, one other thing. One of the things that I wanted to make sure made sense with XYZ was that last bit of my presentation about how OAuth2 stuff and XYZ stuff plugs in together. So I went and dusted off the MITRE ID Connect project, which, quite frankly, I haven't really paid much attention to in a while because it's there, it's stable, it works, it does its job for the most part. And but this is an old OAuth2 and OpenID Connect server, and I grafted on the XYZ endpoints without changing the data model. Like, it can still use the same client registration systems underneath, but they're all exposed, and all the scope management systems, all of that stuff, but they're all exposed by the XYZ protocol. And to me, that was proof that we had place to plug in the legacy stuff into the new system. And I think that that's the best way to move forward with something like this, is not to have strict backwards compatibility, but to have a way where you can see, like, okay, I can use this and plug it here and take this and plug it here, and it looks different, but I can recognize it. It's a very long answer to your simple question.
No, it's a great answer. Thank you. Let's open up for others.
Yeah, may I ask some practical question? What is the protocol for the resource server interaction with the authorization server? Is it something new, or are you just sending the token and that's?
So much like OAuth2, in Gnap, we're not going to have a single protocol for that because different deployment scenarios are going to have different needs. So you can either bake that into the token itself, and there are existing token formats, and people will come up with new token formats that they can do for that. We will have a version of token introspection for Gnap, which is one of the specs that I worked on in the OAuth2 space, which allows you to send the token and get information back in a callable thing. But you also got to keep in mind that there are still plenty of deployments where the auth server and resource server are just two controllers on the same piece of software. And so their communication is literally reading the same database. And so if we were to have a formalized connection between those, that would be overkill and sort of overly prescribing what that space looks like. That said, a key portion of the GNAP charter, which this is all being worked on, this is all being set up in the IETF literally right now. I'm still having conversations with the security ADs like this afternoon. But one of the key points to the charter is that we would have a consistent data model for the resources being requested, so that object structure that I showed for the request, but also for the access rights being granted. Something that OAuth never did was define kind of what a token means. It also never defined what a client really is, or what the aspects of an authorization server had to be. And so because of that, OAuth2 has kind of had those bits patched in over time. So dynamic registration, we invented a client model because we didn't have one. For JSON web tokens, we invented a token model because there wasn't one. For the discovery specification, we had a model for the auth server because there wasn't one. And so the goal is that we're going to have a consistent data model that can then be expressed in a multitude of different ways depending on how you're deploying it.
Yep. Thank you. So so I see some problem, for example, with the current OAuth 2.0 and access control in a space, how requirements are distributed, because okay, you can have external identity server, OAuth server, and then when we have to check the access control, where the access control rule should live on a resource server, but they need some information from identity server about the user, about some user data and stuff like this. And it looks like they're like a couplet, and there is no clear protocol how the resource server can get data from the authorization server, which keeps some identity data, I don't know, some rules and consent, and vice versa, because when we sometimes at the time when the request is coming, so the resource server has some additional information which may be helpful to make decision. Is it okay to do? And maybe some protocol like hook between the resource server and the authorization server would be nice.
Yeah, so that would be sort of a next generation of the token introspection type of thing. And when we wrote token introspection for OAuth2, we were kind of bound to a lot of the assumptions and models and a lot of the syntax of the OAuth2 world. It's my hope in GNAP when we get to the point of addressing that piece, that we actually manage to make that more flexible, to make that work a bit better. So all of the things that you're talking about, I personally wouldn't expect all of those to be expressed in kind of a core introspection protocol, but it should be really, really clear how and where to add that stuff. So something like a FHIR profile for GNAP token interest or the GNAP token model, not even token introspection, but the GNAP token model, would be able to say like, oh, here's how you do this type of thing and whatnot, similar to what we did with the HEART project and the OpenID Foundation, what SMART has done with its scope definitions and whatnot.
I'm just working on a question. In the US, anyway, there's a number of networks that are working on implementing FHIR that have become multi-hop.
Mm-hmm.
So you have the eHealth Exchange run by Sequoia, you have Tafka, which will be, where the requester and the responder are 4 or 5 distinct separate hops apart. So things like, having to manage the keys all the way through that, because they could change, they could, depending on how the certs are being handled, that kind of thing. In OAuth, that makes my brain hurt. Mm-hmm. So much so that Kafka won't have FHIR for a while because there's no way to do an OAuth over a multi-op network without causing everybody's brain to hurt. Mm-hmm. So if GNAP or XYZ can manage that and handle it in a way that doesn't require bypassing it. Because right now you say, if you got redirect, TEFCA does not allow you to bypass it at any stage. So all information must flow. There needs to be either through a JOT or through some kind of structure. All information needs to be able to passed back, preferably in one exchange, so that the FHIR query can be relayed across. That's the easy part. But setting the authentication, setting the dynamic registration if necessary, that kind of thing needs to be part of a security and authorization protocol. And so far, nobody seems to want to touch that with a 10-foot stick. In comes XYZ. Please do this for me.
So I don't know enough about the details of the structures you're talking about to fully comment on it. But I can say that there's definite interest in managing deployments and setups between ASs and RSs and even groups, the trust relationship between different groups of things in ways that OAuth2 really doesn't have a way to think about. It's not even that it doesn't handle this, it just doesn't have a good model for something like this. For example, I was talking with the Solid Foundation, and they are part of what they're doing is really kind of turning the web up on its head. That's kind of their goal. And so a lot of the assumptions about what a web server is and what a client and API query is just kind of go out the window. And you can make OAuth work. I help them write a profile to make it work, and you can bolt it in there. But it's weird. It's not the best fit. And so one of the goals with XYZ, and therefore hopefully Grahame, is to be able to address those types of, I hesitate to call them non-traditional, but because what is tradition of 5 years ago on the internet? These novel ways of deploying and looking at things. So is multi-hop part of that? It should be part of the conversation. So I really encourage you to join the TXAuth mailing list, because we're discussing what use cases are going to be driving things right now. And that's a really interesting one. To give you an idea, some of the others that people have been talking about is how do you do app-to-app communication? So you're not interacting with a web server at all. The user is interacting completely on different applications. This is a big deal in the financial space, because the banks want you to go to their mobile app where they've got local biometrics and all this other stuff. They don't want you to go to the website where they lose all of the session information. And so that's a driving factor. But there's also groups that are interested in having sort of consortiums of authorization servers and so, for example, you make a request, your client makes a request to get your license information, but it doesn't know which bureau to get that information from, which state or province or whatever, until the auth server comes back and says, oh, I know which user this is, so I'm able to tell you which resource server to call in order to actually get their license information. And so those types of sort of transitive trust relationships are definitely going to be things that are going to be driving how this stuff works. And I think it's vitally important that we talk about this stuff early and often in the Grahame process, because if we don't, we're going to end up with OAuth2 that's been rewarmed and given a slightly prettier syntax. And that would be a terrible, terrible wasted opportunity. And it's not something that I want to see. Speaking of rewarming OAuth and its syntax, I do want to point out that for those that are very deeply into the OAuth2 space, there are a suite of extensions to OAuth that kind of backport some of the functionality that's in XYZ, and which isn't to say that they got it from XYZ, but it kind of copies that style of functionality into the OAuth world. And these are the pushed authorization request, which gives you an intent registration pattern in OAuth2, but by jumping through some weird hoops. The rich authorization request, which gives you that multi-dimensional object structure, but in a space that has to still contend with external scopes and a bunch of other stuff. And also OAuth2 doesn't speak JSON natively, so you've got to cram that into query parameters now, which is not the best. And then there's a handful of others that have to all work together in order to kind of make this work in the OAuth2 world. And it works, it functions, I've implemented and deployed it, but it's a weird fit. And the whole goal of XYZ was to make things work in a way that was consistent and had been kind of designed together from the start instead of patched together.
So Justin, I'm sure that folks have more questions, and thank you for sort of sharing the overview of this work. I think we ought to move on because we've got a number of presentations still in the queue. Okay. And I realize that I need to up my time management diligence. So we've got 1, 2, 3, 4 presentations left. And I'm going to round down and say 90 minutes in which to do them. So I'm going to try to hold tight to no more than 20 minutes per, and I will stick to it. So I'm going to apologize in advance, but I'm just going to start working the clock. That means if you're giving a presentation, the more you stick within time, the more time we'll have for discussion about your presentation, which is always the most important thing. But with that, I have just resorted based on current votes and Matthew. If you're ready, we'll take you up next. I'm going to say 20 minutes from what is 7:25 my time. I built in a 2-minute slot there, but I'm going to say, 7:44 my time. There we go.
Okay, thanks, Josh. So just right off the bat, I don't have a cohesive presentation. I'm going to be jumping around a few different documents. Hopefully I can get my story out there. And I think this is a good follow-up to Josh's and Nikolai's presentation and their concepts. So to get started, let me start sharing here. And give me a thumbs up if you see the screen.
We see your screen, but your relevant window is kind of small. There we go.
Is that better?
Perfect.
Okay. I want to talk about where I'm coming from to kind of get to where we ended up going. And so I work for Resmed. We're a large global company, makes medical devices. And our systems right now, this is kind of one view of one of our systems, and you see the spaghetti in the middle there, and you see some medical devices on the right where data is being collected. We have this system alone, which is kind of our largest system. It has about 13,000 different tenants, different customers. Globally, Resmed has tens of millions of patients that use their medical devices, but this system we're looking at, I can't say exactly, but I could say that over 10 million patients are being monitored by this system. Those devices on the right, they have cellular data modems built into them, so they transmit data every day. Some of our primary products are sleep apnea devices for treating sleep disordered breathing. So I would even venture to guess that there are a few people who are watching the call today who are being treated by one of our products, either our masks or our machines. We've collected over 6 billion nights of data in the last 9 years or so. So as you can see, I'm already starting with a very interesting data space. I've got a great data set to work with and deal with. And so almost 2 years ago, started looking at, okay, how can we better organize this data that's coming in? How can we better organize the care domain, especially in what we consider a multi-tenant system? And what's one of the things we need to be able to do with our multi-tenant system is to allow tenants to share access to patient data across the tenancy. So we don't really have the advantage of pure isolated tenants. We need our workflows allow tenants, either whether they're physicians or whether they're other care provider organizations, they will need to access patients that are managed by other organizations. So one of the earlier problems I looked at with regards to FHIR and using FHIR as a sort of a native data model to represent our care domains is how are you going to control access? And that's where I like using the term access control with regards to what we're doing. I think that's exactly what our topic is today. So if this hasn't given you a headache looking at, I'm going to go ahead and get rid of it and bring up a little kind of a slightly simpler design. So over on the left side of this diagram, here under the air view box, we see a more simplified view of what we were just looking at. A lot of these different applications that reside in that air view ecosystem. Over here, aptly named the FHIR zone, is where we're standing up our native FHIR technologies for a native repository. So we have a FHIR engine, and this happens to be built on the FHIR server, which I'm sure everybody's familiar with. And access into the FHIR zone is through this gateway. So coming in, talking about RESTful interoperability, the extent to which OAuth2 is used is to identify the client making the call. So we expect that by the time RESTful call is coming in there, it has some set of tokens, OAuth2 related, and that those tokens they have a claim identifying who that client is. So that could be a patient, where we have a number of patient engagement applications. So that could be a patient that has an identifier that maps directly to a FHIR patient. It could be a practitioner, i.e. one of our clinical users, somebody who belongs to one of the tenants. Or a claim could identify the tenant itself, the organization, where that call is coming from a system, some other automated system. So by the time it's coming in, for us, the OAuth has been negotiated, everything. We trust that we have whatever trust mechanisms in place. So we really don't concern ourselves too much about what else is part of those OAuth workflows, other than being able to identify specifically who is making that call. And that call, as you can see, gets routed from the gateway into several different microservices. This is not a complete diagram of what we currently have, but it's kind of an older one. But everything eventually makes its way to that FHIR engine, the FHIR server, which is where an ultimate action is going to happen. Something is going to be created or read or updated or searched. So we look at those 5 different possible actions. And in that life cycle of one of those actions, the FHIR engine will go out and talk to what we call our security architecture on FHIR, the Sapphire service. Now, before anybody says anything, I came up with that acronym about a year and a half ago, and then just recently, a couple of weeks ago, just learned that there's a product out there called Sapphire. So you don't need to remind me. I'm going to stick with my Sapphire. All right. So I want to give you guys this sort of view, and then I want to start mapping it to sort of Josh's first diagram, where he says you've got a request, you've got some magic, and then you have a response. So that for us, that magic component is right here. And now let me back up a little bit and switch over. So right now, I just brought up the Wikipedia page on attribute-based access control. In the first 2 sentences here, I'm going to try to read off. So ABAC, also known as policy-based for IAM, defines an access control paradigm whereby access rights are granted to users through the use of policies which combine attributes together. Policies can use any type of attribute, user attribute, resource, object, environment, blah, blah, blah. So what that, to me, the implication there, those two sentences, is that the attributes are going to contribute to policies, to decision making. And the best place to find those attributes is in your natural domain. And that natural domain being a FHIR repository. So you've got patients and practitioner roles, organizations, care teams, organization affiliations, et cetera, all these different resources that can contain attributes and references to other objects that are part of your natural care domain. They define how your organization is set up. They define how a patient is managed. And they can also contribute to these attributes that are evaluated by the policy. And this this enables a system to rely on that natural domain that is also driving the various application features and behaviors in how how people organize their work environment, as opposed to having to create a lot of other artificial attributes just to manage security. So that kind of became a real important key driver in looking at how developers would be able to develop applications and features that are driven by FHIR data without really having to be concerned about the security behind it, the security rules behind it, because those security rules are intrinsic in the attributes of the care domain. And what you can actually do, what you can get away with, is being enforced somewhere else. So the enforcement part. So let me move on here. XACML. If you're familiar with it, then you would know that it is a dialect and a model that would apply to an ABAC architecture that allows you to declaratively specify policies for access control. But if you're familiar with XACML, you would be aware of the fact that it is a mind-numbingly impossible to comprehend dialect for defining access control policies. And that might be, I might be a little too kind on that description. It's something you don't want to, if you're an architect and presenting something to engineers to work on, that you don't want to have to tell them this is something you to learn. But from the XACML, I'm scrolling down to this diagram. I find a very useful, wait for it to load here. I find a very useful diagram about the workflow of an ABAC architect. Client making a request to a system. And this request could be creating a resource or reading one, doing searches, whatever. It encounters the policy enforcement point, the PEP. And here it says, okay, well, somebody's requesting some sort of controlled access. So I need to determine if they're allowed to do it. And so the PEP reaches out to the policy decision point. Policy decision point will look at its policies that it has regarding that particular request. And what's in this request from the PEP to the PDP is important. This was touched upon also in earlier presentations. Now I'm going to jump over to that in a few seconds here. The policies are managed by a policy administration point, and additional information that comes from a policy information point, and a response is provided back to the enforcement point to either allow or deny that particular request, and then the request is fulfilled. So this is kind of the basis for that we've been taking. All right, let me close that out. All right, so to me, and I'm trying to tell a story that's sort of building a journey here. All right, this is a great model. How do we leverage it? Well, again, XACML is a very brutal language. So is there anything simpler than XACML? And you find this specification technology called Alpha, which is abbreviated language for authorization. So sort of a pseudocode language for XACML. And the problem with it is that it really doesn't exist in any form. You can't use it. So that's not good. So what I ended up doing was kind of coming up with a dialect, which we called ALF, authorization language for FHIR. And so this is starting to get into kind of the detail of this implementation. There's still a couple high-level things I want to cover. But before moving on, I want to go to that request between the policy enforcement point and the policy decision point. And it's broken rules that determine if the action is part of that request, requested by a subject, the person making, and that's really the basics. And in this policy evaluation world, you can get a permit or a deny or an indeterminate outcome from these requests. What indeterminate is saying is that no policies matched the input request. And so it's a gap. You haven't identified or written a policy to answer that particular question. So our policy enforcement point, if it gets an indeterminate, it's going to deny any of those requests. And then we can come back later and say, okay, now we can write a policy to handle that particular request, and it will no longer be indeterminate. Let me go back to, I think it was this one. No. Yeah, here we go.
So we're getting to the 5-minute mark, and that includes discussion time.
Okay. Well, was I really talking that long? Okay. I guess so. Boy, let me just skip this real. Let me go to shortcut this a little bit. So one of the things that we've done is sort of simplify that policy diagram a bit. So the request goes into the FHIR server, which acts as a policy enforcement point, which goes out to the decision point, which is Sapphire, which is loaded policies from the FHIR engine, which have been encoded as FHIR library resources. And those resources, those ALF policies, so to speak, I was going to show some examples of those. Let me just do that real quick. So it's kind of similar to what Nikolai was showing. This could be a YAML or JSON file, which allows you to import other policies. Has a target predicate, which determines if the request, which is the subject making a request, the action request, the resource being requested of, and some other environmental information. The predicate is, I'm using Spring expression languages here, can determine if this policy applies to the nature of that request. And if it does, then it can run one or more rules to determine based on nature of the request and attributes within your ecosystem, if that request should be permitted or denied or so on. So I'll go ahead and I'll stop here and then let anybody ask questions for time.
Awesome. Well, thank you for the overview. One area I would like to understand a little bit about is how these policies interact with FHIR searches, where you don't know all the resources a search is going to return. Do you apply the policy at search time, or do you apply it to the results, or both?
Yeah. So both, yeah. The CRUD operations are directed, obviously going to be directed at a single resource. So those are easy to deal with. Search is a little bit different. And depending on your organization or the types of searches you support, interacting with a search request can occur several times within the life cycle of that FHIR server. So first thing is it comes in, you've got a search, you make that call out to Sapphire saying, I've got a search and here's some of the relevant information. Sapphire can come back with advice. So the response can include outcomes of either permit, deny, indeterminate, but it can also include advice data, which can be translated into query filtering. So it could be filters applied to your search query. And then you can have a second round as you've gathered up your search results, then you can also do additional filtering on those. So depending on how efficient your FHIR repository mechanism is, in a case of James Agnew's Happy FHIR, he has some pretty good lifecycle hooks that improve the efficiency of being able to filter through search results. So your example would be like, okay, include organizations that are connected to this patient. You might have to ask Sapphire again, can this organization actually be included? Or maybe go through a consent filter where you redact certain information from resources before they're provided back to the client.
Very cool. We have time for maybe one other question, and I asked a question also on Zulip for later, so we can continue discussion in the background.
A quick question, Matthew. So who writes these access control rules? How does this fit you guys' workflow?
Yeah, so the developers can, as we're developing out the system right now, so some of the developers who are doing this, they're writing the access control rules. There's a lot that exist already. So at some point, these rules are going to cover everything. So developers really only just have to focus on their application features and not have to really worry about whether what they're doing is allowed or not, because they're going to get a response in a real system. It's going to come back and say, this is not permitted by this user. So they can, so you can roll in role-based access control as well, which may control the UI or features that are being shown in a particular application. But when it comes down to making RESTful calls, anybody who's writing an application can make any RESTful call. This will decide whether it's allowed or not.
Do you have any performance problem with your access policies? Because I see they can be quite expensive.
Yeah, and so a lot of the queries that go back to the FHIR repository are summarized queries or count queries that produce Boolean results, true or false. So that's a key optimizer there. There's also internal result caching. So if the same query is being executed under the same conditions, it will cache it for a period, whatever is applicable there. But there's other types of searching that can occur, which maybe I'll talk about at some other in another presentation, where you have to do some different types of optimizations, different algorithms.
Awesome. Well, thank you so much for the presentation. And again, I think we've got more questions than we've got time for, but we're going to move on to Chris. And Chris, I'm going to be timekeeper again on this one. We're going to give you 20 minutes starting now.
Great. Thanks, Josh. And thanks everybody who's presented. We've been enjoying these presentations. I'm going to blow through this, I think, really quickly and try to get to some discussion. The title of my presentation is Classification and Locality, because that's how I think about, or how I thought about connecting sort of the end of what Justin was talking about with XYZ or with OAuth. Once we understand the intent, and once we understand who's making the request and these kind of things, how do we connect that to data? And how do we express what the request is, what the policies are and the request is, in terms that are consistent with how we talked about FHIR generally. And I think about in this classification, what is it that we're requesting? And it goes beyond just what kind of resource is this, but very specifically, what is it that we're requesting? Are we requesting not just an observation, but a lab observation or a blood result observation, down to whatever level of detail we need? And where does it sit within the larger graph? The relationships, it's attached to a patient, it might be attached to a practitioner, it might be attached to an organization through different contracts, through different relationships. So where does it sit within the graph? And how do we then connect these things together? So if I were to say, as part of an access control policy, I want to grant read, and this is to a particular permission, grant read to lab results for covered lives, and use that as a permission, understanding that who this permission applies to is something that's not part of what I need to worry about. That's in LDAP, System or Identity Management System. Defining a permission as I want to grant read access to lab results for covered lives. How would I implement that, and how would I describe those things? And again, it is lab results is the classification, and to covered lives, and this would be like an insurance context, the locality is that part of it. And if we squint, we can think about these things in terms of profiles for FHIR and compartments. So really the goal of all of this is to take existing FHIR concepts and sort of really stretch them to be able to apply and understand what we're talking about. To be able to apply the security model to this. And the goal of all this is a few things. The first one, and I think most importantly, is that this brings the security model much closer to other things that are happening in FHIR. So in the implementations I've worked with, we've used profiles to describe what it is that different parts of the systems are producing. If you're in an environment where there's lots of data producers, tightening up on exactly what kinds of things that they're writing or producing is important. And once that effort has been done, that same model should be also used to authorize that system. So we're trying to produce and stay with a consistent mental model so that our access control rules are not something that is completely separate. It's not something that's written specifically in a different context. But once I've defined what lab result means, I can then authorize using that same definition. And that's really important in terms of making sure that our access control rules are you can reason about them, they're comprehensible, and that we're not making mistakes. A lot of times people are deciding what their access control rules are not necessarily super technical. They're domain experts. They're describing the medical data that they're talking about, and they should be able to authorize in the same model. It also so this model also, like I said, leaves the issues of things that are identity management kinds of things off to the side. And then all this, like Josh said earlier, all this has to perform. We're talking tens or hundreds of milliseconds to make these decisions. So how do we use the profiling system to do this? I think it's anyone who's worked with FHIR understands what you can do with a profile and how you can validate things. And that by using these profiles, you can classify exactly what you're talking about down to a pretty fine-grained level with the kinds of healthcare specifics that we need linkages into terminologies and ontologies and all of those things. But really, to make this performant, you have to get pretty clever about what you're doing beyond just necessarily the base validators. So I'll talk about performance in a bit. What happens a lot of times, or has happened in the implementations I've seen, is that you don't necessarily get far enough just by saying, is this valid or is this not valid? What we really want to do is take it down to another level. And this is something that I've talked about in other places, but it gets interesting if you can talk about what exactly is authorized and still use the profile system to do that. So one of the examples I had is a CSR system, customer service rep system, where certain CSRs were authorized to just call patients when triggered by certain events. And really all we wanted to be able to expose to them is the telephone number of the patient, which is one of the attributes of the patient's patient resource in FHIR. So what we wanted to do is redact all the other parts. So we created a profile, patient for call service. We redacted anything that wasn't part of that, that wasn't basically mobile phone number and the identifier that was used to match those up. And then we could use that then to both shape the resource as necessary, but to do authorization as well. So now this CSR is authorized to read the patient for call service. And I can make the clinic patient that was already there into a resource that fits this profile, and then apply that authorization decision to that on top of that. We can also do things like translations and reshaping of other types, language translation. We can provide unit translation. And what's nice about this is that it not only gives us a way to authorize individuals and what they can see, but it also gives us a way for, again, clients to state their intent. My intent is to read an observation in French using white codes, because that's what I understand my clients, and also milligrams per deciliter is how I understand hemoglobin in the A1C. So all of these things sort of wrap together. They're a bit orthogonal to authorization, but at the same time, again, we're linking up data as it sits and client intent and making sure that everything can come together. So many people have talked about policy enforcement points and decision points. So this is sort of how it comes together here, is that a client asks to get a patient. This CSR has permissions that something in some other system has determined. There is a permission that this CSR can read the patient for call resource. And the decision point then can say, yes, the patient 42 is a patient for call, or actually can make it into a patient for call safely. And therefore, it is classified properly. Some optimizations that necessary to make this work. Obviously, validation is a relatively expensive operation. So trying to do a lot of this stuff at right time is important. So, every time you write a resource, you're going to do some base validation. But beyond that, you might look at what profiles are hot, what profiles are necessary for your most common authorization decisions. And then if you get a little more clever, you can start looking at incremental validation. So if I already know that I have a clinic patient SD, if I am authorized to something that's just a small increment on top of that, and I can use that existing authorization to really speed up that process. You can also do things that sit aside. So if a client says, I'm looking for senior patients, and here's what that looks like, and I already have, in my system, I have a senior clinic patient ID, and I realize that those two things are functionally equivalent, or that the senior clinic patient ID is actually narrower than the client's version of that. I don't need to revalidate it, I can use that. So there's a bit of a static analysis aspect to the profiles that can be used to speed these things along. And all this stuff has actually been implemented to various levels. So we're not talking just about sort of bare concepts here. These are things that are possible within the existing FHIR profiling system. So the other half of this is locality then. So once I understand what I have, I have a patient recall service here. I need to understand how that then relates to the authorized user. And again, in FHIR, we have this web of references and have codified those into compartments through the compartment system. So, for instance, you have a patient compartment that includes basically all of the things that are connected to a patient or directly have the patient as a subject. So if I am authorized to some profile within a compartment that I am the patient of, these are the things that I can also see from a locality standpoint. Organization, similar. So you might have practitioners that work for an organization, and therefore someone attached to the organization might have rights to see the records that the practitioner has worked on. Or I might be an insurance organization, and again, I might be a covered life as a patient, things like that. So all of these kinds of traversals are what's possible. Compartments have a little bit of a limitation in that ideally I'd like to define my organization compartments, which is not a standard compartment, by the way, but I'd like to define this organization compartment simply as a linkage between the org and the patient, and then use the patient department to expand beyond that. So linked definitions is something that we implemented as an optimization of that. But the idea here is that you're creating a graph traversal piece to this that then layers on top of that classification. Some of the compartments that I've used or we created, patient, person, especially in situations where you have a lot of identity management kinds of things. You've got lots of different records that actually belong to the same person, and the user might be attached to that person rather than to the individual patient records. So that's an interesting one. Practitioner who is the direct provider, practitioner who is not a provider, but someone who is in the organization, such as a clinical ops person or a customer service rep, something like that. Someone who is directly attached to the organization themselves and has ownership rights or access control rights. And then traversals that go through consent is really an interesting thing. So a lot of these traversals really should block if there's not a consent, especially in any sort of patient access. Any access that's given directly by the patient through an informed consent or through a consent to share, that traversal then will go through that consent resource. And finally, some of the optimizations for this, again, usually this is optimized by right time pre-calculation. So the number of compartments, the number of traversals that we're talking about, typically is quite low in the enterprise implementations that I've done. There's only a handful of places where you start. There's only a handful of places where you would authorize a client, and you could pre-calculate the distance from, say, the node to the description at the bottom of this to any of these compartments at right time, relatively efficiently, and then say that this prescription is connected to these handful of compartments, and that would be a pretty efficient way, or is a pretty efficient way to do that. Especially if you can understand that things like, again, that organization is basically the patient department plus one or two extra hops, or practitioners is the practitioner department plus one or two extra hops, so you can do some clever things there to optimize. So I'll stop there. Happy to answer questions or have more discussion, or give some time to the next presenter.
So I'll start, Chris. This is super interesting. You mentioned a few of these kinds of compartments as kinds of graph traversals. And I'm wondering, like in the implementations that you've built, is that a conceptual model, or are you actually using under the hood, a kind of a graph traversal to answer those membership questions?
Absolutely using a graph traversal for that. I've used a RangoDB. I've used the graph capabilities in Elasticsearch. There's lots of different things. I mean, it's not strictly, I guess, something that would have to be a graph traversal. I mean, you could do it with recursive SQL or other things, but that is definitely how the implementations work.
And if I can ask one follow-up there, when you're thinking about traversing those graphs to figure out whether a resource is in or out of a compartment, and you're also evaluating things like FHIR search parameters, are those using two different mechanisms that get overlaid to produce a result, or are those both part of one generalized kind of search system?
Yeah, so the search we optimize search very heavily on the classification side. So if you were to think about profiles as a collection of constraints and search also as a system of constraints, you could do some stack analysis on the search and look for overlap between the two. So you know that I'm authorized to a handful of different profiles, and I can tell if the profiles that I am authorized to include the kinds of constraints that the search also does, so that, that the overlap is there, and therefore this is a search that's going to produce results that are within my scope. And it's not, it doesn't necessarily need to be complete overlap, because you can then do analysis after search results come back, whether the things that are left still qualify. On the traversal side, it's less clear, because if you just do a bare search and observations, exactly how that works. You could, I suppose, optimize by adding, sort of chain search parameters to that, but I haven't bothered with that at this point. Usually the classification part of it drops the number of candidates low enough that it's not a big deal.
Thanks.
Chris, so you're building this system on top of profiles, and how you inject this profile information? Is it part of the request, or your access control engine decide which profile to use? I mean, do you violate the REST principles or not?
Not strictly. So the request itself can come in bare with no profile on it at all, and in the permission model, then the existing grants will then tell you what profiles it has to apply to. So you'll basically get back a result or look at a result and say, all right, so what profiles
what if the client, for example, permitted to see two profiles? How do you handle this situation?
Yeah, the client might, the permissions, the list of permissions might be quite long. And you handle that by, like I said, the static analysis of what is it that's coming back versus what is what is in that list of permissions. So if they've got permissions to a dozen different profiles, and you have a resource in hand, and you know what profiles that resource already conforms to, you can look for one of those in the existing grants. And if you're able to do incremental stack analysis, you can also say, find the other things that are close to it, and then we'll do addition validation as necessary to try to fit it into one of those. Now that's assuming that the request is for a specific resource. If the request is a search, then it's a little bit trickier to limit the search, I guess. But typically, in the search case, you're looking for a profile then that has, like I said, similar constraints to the search parameters.
Thank you.
It requires kind of a symbolic representation approach, though, to profiles.
My idea is to still try to be RESTful and, for example, just include the name of profile in a request. So I'm trying to request a 42 with a profile like for call center. And then that's otherwise, if you have multiple profiles in permissions, I don't know, you have to merge them or do something else. They can contradict to each other, and we bring a lot of this strange behavior.
Yeah, I mean, and the implementations perform much better if the clients are more explicit. So we did provide a path for the client to be more explicit about the request, but we didn't want to make that an upfront requirement because it just from a developer experience standpoint. But yeah, I mean, if your client makes a explicit request for a particular profile, then that leaves a lot of that stack analysis off to the side. To spend the cost on that.
Awesome. Well, Chris, thank you so much. Incidentally, are there write-ups of kind of this material beyond the deck that you shared? Are there other things we could do as background reading?
Not yet, but watch my LinkedIn profile because I'm planning on writing some things about this.
You may be the first person in LinkedIn whose profile I watch. Thank you so much. All right, we're going to transition over to Kathleen.
Hi, everyone. I'm trying to get the right page up here. Okay, share. Okay, my reason for being on this call was I wanted to make people aware of the work that the security work group is doing in HL7 to bring security label syntax to FHIR. We already have the ability to use security labels to represent policies in CDA and in version 2. There are some unique things about the way that FHIR, are you seeing, you're not even seeing my screen, are you?
We are seeing the DS4 people.
Oh, okay, I'm looking at another laptop and I didn't see it. Great, okay. So the reason that we did this was that FHIR is structured in such a way that it has you could have 0 to many security labels, and they are security label elements. However, security label syntax have a structure that we wanted to bring into FHIR. And these security labels, they can be used to label bundles of resources. It can also be used for clearances in access control. And we're working on a new resource, a draft permission resource, which could also contain the security labels and be used for access control policies. So the examples of security labels are meant to represent policy. Policies have usually some certain dimensions that we try to capture with the syntax that was developed in HL7 in the healthcare security and privacy classification system. And that's the one that's used in V2 and in CDA. So, for example, you can represent a policy such as consent directives, break the glass policies, or even security policies like the U.S. Controlled Unclassified Information or CUI mark policies. So this is I'm just going to show you quickly, this is the overview, and this is the background, which talks about how why we developed it and how security labels can be used to represent policies. And we talk about the different kinds of tags. So security label syntax has tags, which in FHIR speak would just be one of the security label elements. So we have to structure those in some way. And in order to do that, besides explaining how these different tags work, sensitivity, confidentiality, purpose of use, and some use cases, we also developed, I think the most important part, were a number of extensions. And the purposes of the extensions is to allow you to emulate the structure that we have in V2 and CDA and is in the conceptual model of the healthcare classification system. So the main one, the most important one, is the sec label basis extension. And what that does is extend each one of the labels with the policy that it's being used to represent. So for example, if you had a HIPAA policy and you wanted to say the confidentiality code was normal, the sensitivity was HIV, for example, and that the purposes of use were limited by HIPAA to either treatment, payment, or operation, or all three, then you can do it by appending this this extension to each one of the tags that are part of that label and part of that policy. The other thing that we did, and I'm pretty excited about this, we don't really have this in CDA or in V2 labels, is the ability to point to external policies. For example, you can say that it's part 2 substance use disorder consent directive, but you may want to know exactly which consent directive for which patient. So you could point to a reference, for example, a FHIR consent representing that instance of patients. You can also point to provenance resources we have a provenance tag, so you can actually point to that. You could point to a particular law that you want to represent, or For example, it could be a particular policy, like the idea of having permissions, as it has been discussed here. You could point to the actual one so that people know this resource requires this policy to be permission to be achieved before it can be disclosed. And the other one I wanted to talk about briefly is, the classifier. So it's important to know who actually assigned to the security label. And when you go from one policy domain to another, it may be the case that you need to reclassify the security label. So you might keep both labels, but show that the last one was put on by an authority in the new policy domain. And then there's also a need to be able to tell the receiving system that they need to render a particular message to the end user. So for example, CUI, they have to put the CUI mark on. It could be a prohibition with not to disclose without consent, or it could be simply a banner that says confidential. So these are new capabilities for the FHIR security labels. And I think that's about all I wanted to cover, just to make sure that people knew that this was here and that we're trying to standardize the approach for using them. Back to you, Josh.
Awesome, thank you so much. So questions from the group? I've got one if others don't, just in terms of the standardization process itself. So the content you're showing here, I think represents sort of work in progress. Is that right? Can you tell us a little bit about the timeline for bringing this forward?
It's gone through May ballot and we're doing reconciliation now. Hopefully we'll get it in time, but if not, it will be in January.
Thanks. Other questions?
We consider just replace the coding data type with a custom security label data type instead of doing all these extensions?
I don't think we can do that.
Why not?
Nikolai, when you say a custom security label data type, do you mean something that is formally, it matches the security label data type, or something new?
Yeah, because we see that it's not just a system and code, yes, and people want to add more context information. And why not just introduce a security label data type to capture all this stuff?
The security labels can, I don't see that there's any problem with extensions. Is it a performance issue for you?
No.
For Nikolai, your complex extensions look just like looks exactly the same as if it were built into FHIR.
Yeah.
We can take a quick look at one, but let's see where's the example.
I don't know if I can add a comment to that while we search around it, but it may be sort of a practical thing in terms of indexing.
Go ahead.
I was just adding a comment. When you put something into an extension, it doesn't necessarily make it searchable on typical.
Yeah, I'm thinking about the semantic because it doesn't look like it's a coding. So the security label has its meaning, and a guy is trying to give this meaning and why it should be coding. I don't know. Do you consider
that's the way it's been in that's the way it's been in the other, we've been using it in CDA for a long time. There is the CDA DS4P IG, which has been one of the optional certification criteria for meaningful use. Seems to be, and we wanted to emulate the syntax so that we could make transforms when people go from FHIR to CDA, et cetera. That was another reason.
But maybe
I just wanted to say for Nikolai, there is a compartment which could be used to reference, for example, the compartment policies that you were talking about. Sorry, go ahead, Mike.
I was going to ask, so if I wanted to filter on these, right, as part of FHIR search, would you imagine there being some search parameters associated with these?
Well, they are already. I think somebody already showed where they were using using the labels for search. And was it you, Josh?
For the label itself, the code and the system, those have search parameters, but not for these extensions. I think that's the.
Yeah, I was talking about the extension. Yeah.
And that's a good question. I don't know. I'll have to ask John Murphy or some others about how to do that.
And in general, I mean, just in terms of the FHIR modeling side of things, an implementation guide like this that's defining extensions can also define search parameters that, look in those extensions. But not a lot of servers natively have the capability to, well, I shouldn't say that, but many servers don't natively have the capability to read those things and expand what they index. Some do.
That's good.
Yeah, I was kind of proposing that as part of the implementation guide here could be, you should then have these search parameters, and they could be defined as part of that.
Thank you. That's a great idea. I think that the shortcoming, that not being a native capability, is something that would have to be examined as well.
Yeah, and whether they're native or extensions, the search there is a little bit tricky because we're basically talking about composite search parameters that look at the security label and the group who applied it, or the security label and the basis on which it was applied.
Yeah. Good feedback. Thank you.
And in FHIR, we already have like a underscore security special case. So probably if this specification will be successful, then maybe the underscore security can be extended, like a really special case.
Good. Well, Kathleen, thank you for the overview. And I think we've got one more presenter, so I'm going to transition over to Michael.
Yep, thank you. I think, okay, there you go. I am going to share my screen here. And let me know when you guys can you see my slide in presenter mode now?
Yep.
Perfect. So for those of you who don't know, I'm Michael Hansen. I work at Microsoft on our FHIR services and other things, and we struggle with this access control problem a lot. We get lots of questions from customers that have anything ranging from ideas or requests for help to and anything in between. And so we really struggle to try and figure out what we should implement to sort of help out in general. And we're hoping that there could be something, maybe not necessarily in the FHIR specification, but it could come out of a group of some consensus where we could, follow some common guidelines. And I think actually what I'm going to talk about here is some discussions that we've had internally on our team. I've shared it with a few other people externally. But I think, to quote Chris, if you squint, it'll look like it has some similarities to Nikolai's compartments and also the stuff that Chris is talking about in terms of localization of the stuff that you're trying to access. I think there's a lot of commonality here, and I think we could probably come up with some joint things. So I'm not married to the specific thing that I want to present here, but it's more the concept of being able to express these things. So just at a high level, we've already covered this, but there's really, like, in my mind, two different pieces to this. There's how you interact with an identity provider, present your credentials, consent to an application doing certain things on your behalf, for instance, and then ultimately you end up with some token, or the application ends up with some token that it will then take to your resource server, to your FHIR server. For us at Microsoft making a FHIR service, that is where our world begins. We interact with Azure Active Directory, which is our sort of main identity provider. But really at the point in time where the request comes to the FHIR service, all that stuff that's in the identity provider and information about the user, whatever is not in the token, we really don't know a whole lot about, and we don't assume that we can reach back out to the identity provider and make additional requests and so on. I think for a lot of people that make dedicated FHIR services, that is the situation that they're in. Whatever decisions they have to make has to be made starting from that token that comes in. So you have to figure out who it is or what it is. Is this a device, a patient, a practitioner? What role do they play? And then somehow scope the access to what this user or principal is allowed to see. And Nikolai, there's definitely some stuff around what you say in terms of being pure to the rest thing. Like, do we sort of rewrite the context so different as different requests come in, we would make certain assumptions of what they're actually accessing based on what's in this token. But I would say here, if we consider this token as being part of the request, I think it still applies. We're deriving some information from that. But anyways, that's where we start figuring out with what goes into the FHIR server. And then what we were then thinking about is some kind of we could have some kind of expanded version of compartments. And I think this goes to what Nikolai said as well, that right now there are a few compartments defined. They're actually very nice to work with. They're indexed, it's super easy to access and so on. But we may need to expand this concept a little bit and allow these compartments to be parameterized in some ways. They're actually already parameterized, like the patient compartment applies to a specific patient, but there may be more parameters that go into that, and we need some more expressive ways to define those. And then we have to have a way for these compartment parameters to be resolved from information in the token that's presented. So we can't necessarily make any assumptions about this being a job or something, and that there are claims in there and we'll pass them in a certain way. This could be an opaque token, but we can make some assumptions that a server might be able to resolve information from this token. So if we have some way of expressing that, then that would be great. And then basically create it so that these compartments effectively become separate endpoints. And I think this is also very much along what you said, Nikolai. Basically, when you go in and you access one of these specific compartments, you're effectively accessing it's in the same FHIR server, but it looks like a different FHIR server. It could even have its own it could have its own capability statement. Like at this endpoint, I can only see patient and observation. And it could even use a different identity provider. Like we're expecting at this endpoint, we're actually expecting a token that comes from, it could be a consumer identity as opposed to a corporate identity or whatever it might be. So that's kind of the way that we think about it. We would define these parameterized compartments. They effectively become new endpoints on the FHIR server. And when you come in there, it looks like a fully functional FHIR server, but you're really operating now in this compartment. And so what could this look like? And this is completely made up syntax, by the way. This is like this is just pseudo stuff. Like what could this actually potentially look like? So I'm defining here a compartment which is my patient compartment, and this has some variables, some parameters that can be used in defining this, and I then use a function which I'm just here arbitrarily calling current principal as patient, and I'm grabbing the ID of that patient. So this now, I'm not making here any assumptions about how this would be done. That can be left up to a server. Like it may have direct access to the identity server and can go look up some things, or it may grab this out of a claim in the job, and I'll get back to that in a second, what that could look like. But in terms of the FHIR part of it, we don't have to make any assumptions about how that's done. We just say a server could have this ability to, given the token, figure out what this principal is coming in the context of it being a patient. Is there a patient that matches this? And then I can define a number of segments, and these can have complex relationships that are much more complex than what I'm describing here, includes and so on. But basically, these are FHIR searches that define graph segments that would add up to this parameterized segment here. And that is basically the new context that you would come into when you come into. So if I do a get down here at the bottom, my patient compartment, I just put an underscore here. This is arbitrary again, right? We would have to define exactly how do you, specify what compartment you're accessing into, and I'm now accessing observations. It would be for this specific patient's parameterized compartment where I'm allowing these resources to be there if they are of this patient type, or if they refer to this patient. And then one other thing that we added on here, which could be optional or even a totally separate thing, is that there are certain filters that will get applied. They could be applied on read, on write, and so on. Here in this example, I'm saying if you try to write something into this compartment, you're not allowed to write to anything. I'm removing everything, except for patient contact. Right, so I'm only, as a patient accessing this compartment, the only thing that I can modify is my contact information, and that's the filter that I'm applying. This is a write filter, could also be a read filter, and so on. That will, and in there could be all sorts of expressive things that in terms of how this data gets transformed. Right, but this was just a basic idea. And then in terms of like this parameter extraction, as I said, we could leave it up to the server how they implement it. So if this is an EMR, they may have a way to say current principal as patient, and however they define that internally is up to that particular EMR. But you could also have a way to define for a file service, if you're a file service provider like we are, like some kind of way of how these things are defined. So for instance, in this case here, if I had a patient here and I've added a security tag to this patient, and I've arbitrarily created some system here, Microsoft something, right? And this refers to my object ID in my Azure Active Directory identity provider, and this is this GUID. This patient is actually this particular patient. Then I could define or allow a user on my server to say, I'm defining the current principal as patient function as this search here, where I'm looking up security tag with this system, and then here I've written out the GUID, but of course this would be parameterized based on the on this claim that comes in. And some of the things that we thought that would be useful to have in these functions, that again a server can decide how it implements these, are things like claim values, right? If it's a job, references that take a certain element and returns this in a form of a reference type. These are tools that will be used in expressing these. But then things like current principal as patient, current principal as practitioner, as related person, as device, and so on, and there could be others defined, right? So this could be part of how we actually put this together so that you can use these in expressing your policies without necessarily telling the server how to implement them. And a server could possibly publish which ones that it implements. It may have some, but not others, right? So this is something that one could think about how we implement that. So I think I'm gonna stop there with that. I think there's a lot of overlap with other presentations here, but we can discuss and take questions. So now that's it.
Awesome, thanks, Michael. And I've been sort of commenting a little bit, and Grahame is still engaged on Zulip, even though he had to leave the meeting. I think there's one common theme here, which is a lot of folks presenting here have talked about the value of being able to name some set of rules in a nice package that's sort of at a practical level that has some reuse. And compartments have surfaced as something that meets that bar today, but isn't quite flexible enough for people to use in all the scenarios where they might fit. But I think this is it's a really promising area. I'd love to hear thoughts from others.
I would say just on the compartments thing, like one thing that makes it really inflexible right off the bat is there's only, X number of them defined, and only HL7 can define these, right? Full stop. This is like, so it's pretty restrictive, just right there, right? If there just was a more, flexible way to define more compartments, I think that would be a big step forward. You could latch onto that. The good thing about compartments is a lot of the time there were, as Chris mentioned, there would only be a handful of these for a given scenario, maybe a few more than that, right? But you could actually index them on write. And so new resources come in, you could index it, so it could be made very efficient in terms of implementing this.
Michael, we do have a label. We do have a label, a tag for that, and that was the idea of using an extension to point to a compartment that was predefined. So it could be anybody's compartment. You just on that, and there may be better ways to do it, as Nikolai was describing. But that at least that fits into the syntax we have, and you'd be free to add any kind of compartment you wanted there.
Yep.
And Michael, I liked how you extended the principle to related person and device even. I thought that was kind of interesting. How would you take this approach to dealing with population access control, population management? So where you had access to a population of patients, how would you segment those?
So I had some very simple examples of these like relationships of the in the graph, but actually we internally had some much more elaborate examples. And I think it really comes down to this thing about the sort of graph relationships that you can express, right? If you said, well, it could be something simple, it could be hard to implement, but say here's a person comes in as practitioner, and this practitioner compartment has all the patients for whom this practitioner participates in their care team or something like that, right? So this is now a little bit more elaborate than just some very simple file searches of some resources. But this is how we imagine that this could be expanded, and a server can decide how far it's willing to go, right? There's clearly some performance usability trade-off. You can express quite elaborate things that wouldn't really evaluate very efficiently. I mean, some of them would actually take a very long time, right? So I think I don't know if the file searches themselves are expressive enough, or it needs to be something like something more like graph relationships, and we need to work more on that. But something like that. It's not really an answer.
Or we should make file search to be able to do this, because otherwise it's useless if we even could not express the access rules.
Yeah, no, but it's actually a good point. I mean, I think out of this sort of work with defining common sort of access policies that a lot of people use, it could drive definitions of other search parameters or search parameter types even that are specifically suited for, sort of figuring out what these compartments are. I think, but you have to start somewhere. And I actually think the nice thing about it is you can start simple, like say, well, we need an ability to expand on this compartment concept. Here's how we're going to start. We're going to add these things, and we're going to add these ways to figure out who the user or principal that comes in are. It doesn't cover every use case ever, but this covers some of them. We can start with those, and then things will have to go as they're needed, and people show use for them and in prototypes and other things, right?
This is Kathleen. I want to point out that there is a place where they're doing a lot of wishing we had an answer, and that's all the Da Vinci projects where payers and providers are needing to exchange information, but they cannot exchange more than the minimum necessary, which is very much like having a pre-approved approach to compartmentalizing things. So you might get a lot of support from that community. They need this solved.
Yeah, and I was thinking about the compartments, and we can decompose compartment up to the operation. So I think the fine-grained piece is the operation, because the compartment is just a set of operations. Yes. And I can imagine compartment which consists of one operation, and probably we have to look not only on compartments but as well on operations. In FHIR, we have a operation resource, which potentially can be extended. And the compartment is just a bunch of operation resources, which are pre-configured somehow. So just maybe look from this point of view at the problem.
Well, what I found is it's very business specific. You can come down to some generalities for doing these more complex access control problems or formulas, but you still have a lot of business specific requirements as to who can access what and based on what set of policies or rules. One of the things that I was answering a question after my presentation, one of the last questions I was answering regarding search performance or efficiencies or things is kind of developing alternative indexing mechanisms that include some of those access control attributes. And those are always going to be based on what the business says is allowed to do. So it can be, from what I found, at least, to get performance out of a large population of anything, patients in particular, you've got to know what the rules are, who can access those patients. You can, whether they're cross tenancy, insurance companies to patients, people in accounting, people in different care teams, care providers, or general practitioners that are identified in the patient record, and so on and so forth.
But I think I don't know how directly related it is to what you just said, Matthew, but I think it's important to think about something that a FHIR service provider or somebody who has a FHIR interface, could be an EMR, has a way to just express these even with words, right? So here's a compartment that is all the patient stuff that I as a practitioner have access to, or whatever it is, right? Something that actually is expressed in words, but the implementation detail of how that is actually done, that it's kind of up to the server. But then still have a layer where we can also have, say you wanted to express this in terms of FHIR and searches and how segments of the graph are related, then you have that option as well. It's a little bit like the strategy that the subscription stuff has taken, right? It also started as something that was kind of very flexible in the sense, right? You just subscribe to a FHIR search, but it also turns out it was not really implementable at scale, right? And then it now has switched to more like a pops up model where a server can say, here's a topic, here's all the admission and discharge information. It's a detail how we implement that, but if you subscribe to this, we will emit an event, right? And I think of these kind of in the same way, that these compartments, these extended parameterized compartments, how a server chooses to implement them, it could be pretty transparent or it could be completely opaque. It actually doesn't matter, right? I think we should prepare for both things. And similarly with the token that comes in, I think anything that relies on it being a JOT where you pull out a bunch of claims and here's a claim called FHIR user and so on, I don't think will work in general, right? We cannot make that assumption that it's that type of token, right? So, instead saying the FHIR server should have an ability to, given a token, figure out what patient would this be in the FHIR server if it's a patient, right? And leave it up to the server how they implement it.
Yeah, I agree with that. I don't think you're going to come close to packing all the information you need to in a token. I think it's just it's good for identifying who's making the call. Maybe a little ABAC for the application, but beyond that, you need to have this compartment or sort of care domain idea coming in.
And also, depending on what kind of FHIR server you are, you have different tools at your disposal. You may have actually the identity provider is like baked into it's the same piece of software, right? They have the same database, everything lives in the same place. So you have some totally different tools compared to something that uses an external identity provider that you can't reach back out to, or things like that, right? So I think there's a lot of different scenarios, and I think we should try to be able to accommodate them if we can.
And probably, so when we're talking, the Josh started the talk about, and you mentioned that we can imagine that multiple conformance statements. And I think we should think in this area as well, because now we have multiple versions of FHIR. We have some distributed system with multiple FHIR servers. So we are losing sense of one file server. And if you think like a compartment on steroid, it's really like a virtual file server. And even for the access, like in XYZ probably or something like this, your first request can be give me the proper base URL so I can work with. I'm providing you some details of the user, and then this endpoint can define to which compartment or the virtual file server it should be redirected. The same problem like XYZ trying to solve with the OAuth 2.0, yes, these hard-coded URLs. And they replace it with some layer when they have one endpoint to request, and then they get back the references to work with. Probably that can be solution. If we imagine, for example, like the huge installation like HIEs, where probably can be multiple file servers, yes, or partition the installation and stuff like this. So probably we get rid the static base URL, and then make some resolution, and then we can redirect to the compartment.
I sort of imagine though, but this may be naive, but I sort of imagine that from a given client's perspective, there would be a single FHIR endpoint. So let's say I'm a patient app, phone app or something, right? I'm gonna go, I've been given this FHIR server, it's, or some, and then my patient endpoint, right? But that's my universe. It's the only FHIR server that's there. It just so happens that is accessing a specific parameterized compartment or slice of this FHIR server. But from my little client corner of the world, that's what's there.
But it can be done through the discovery. I'm against. So I'm again warned about violating REST API and endpoints like my patient, because, for example, I can just show you when it will stop work. For example, you're doing like a patient portal, and then you decide that the user can access multiple patient records.
Yeah,
and then you have my patient and my patient and my patient. So it's better.
I don't hear Michael saying he needs the URL that we give a client to be a fixed string like my patient. I think the contract Michael's describing is the client gets a URL that it can treat as a fully functional FHIR server, restricted to only the things it's allowed to do or see.
And then we can have this discovery endpoint where the client go and get this URL.
So there's a robust discussion or maybe head bashing on Zulip right now, where I've sort of brought along the idea of this compartment, expanded compartment capabilities. And if I want to mischaracterize what I'm hearing from Grahame and from John, it's basically, you're talking about access control, which is the internals of FHIR servers. And it's not the kind of thing we would want to have as an interoperable set of definitions. That's really not really what FHIR is about. You should be looking at consents and permission resources that can capture the computable definition of what's supposed to happen. I look at that and I say, well, there's obviously an unmet need because a bunch of people are sort of converging in this direction, but it's not obvious whether it's a thing that HL7 will want to take on.
But I think what I'm saying is, but by the way, by this my patient, I didn't mean that it would be different for every patient, right? That is just a specific URL, just some specific URL. It could actually be a totally different domain name, right? How a server chooses to implement that, that doesn't really matter. It just means when I go to this endpoint, I am now scoped to the context that's defined by this, whatever expanded parameterized compartment, whatever we choose to call it, compartment on steroids, right? That is what I'm scoped to when I access it. And that actually, in my mind, is a way to address the concern that I think I hear you say that's being voiced, Josh, is that this means that when you come to this endpoint, this is just a FHIR service. There's nothing specific that needs to be known about auth or anything else. It's just that I have implemented a server that where I can define this in multiple. I can have multiple of these that adhere to different policies. But when I come to that endpoint, it just looks like a FHIR server. I get a capability statement on it. At this FHIR server, I can see patient and observation, and I can search these three things.
To get there, but by the time you get the client there, somebody wrote down a compartment definition that is describing the behavior of that FHIR server with respect to a full server. And the question that I'm asking, or I think I'm channeling from Grahame, is, did somebody have to write that down in an interoperable way, following a expanded compartment definition spec from HL7, or is that just an internal detail of your server how you do that?
Well, so I think that's a really good question. I think if nothing happens in terms of consensus in the community and we come up with something, then I think it will be, that's an internal detail to my FHIR server and how that operates. Aidbox is going to do it in one way. Azure is going to...
Probably this is definitely the problem of the vendor. So if we have now a definition of FHIR server with a capability statement and all this stuff, so we can make these generic FHIR servers configurable to provide API to multiple FHIR servers in one instance. And it's probably up to us to describe it as a compartment or something like this. So
yeah, so what I wanted to say was that in my world, or in my mind, this could be something that was part of the FHIR specification. Like, this is how you would describe it, but it doesn't have to be, right? It could also be something that is just a consensus that lives outside the sort of main FHIR definition, but like, here is a group of like-minded, or whatever you want to call it, people that have a stake in solving this in this problem space, and we would like to solve it so that if I write a compartment definition or whatever we want to call it for the Azure API for FHIR, and I decide I also want to run Aidbox, I can take the same document and use that again. This becomes a shareable artifact that is understood in the community of server implementers, or I can take it to Happy FHIR and it would work on Happy FHIR, whatever it is. I think that would be a good outcome. I don't know where that work should live, if that's part of HL7 or somewhere else. I don't know the community deep enough to make that.
Probably it's not a part of HL7, but so when we will exercise on this, we will probably find something which can be fixed in HL7 to help us to implement.
I think a great outcome of this could be if a few implementers of servers, it could just be us here, right? We decide here's something fairly simple. It's not the full broad scope of anything, but here is a simple use case, and let's go try and implement it on our servers, and then come back and say, actually, this specification didn't quite work. This was not expressive enough. There was this corner case. We missed this one. We noodle on this a little bit, and then we have something to work on, right? And then we can figure out where it logically lives. But instead of sort of doing an HL7 thing, which is sort of coming to a consensus of forming a committee to start an initiative to build it becomes very unwieldy very quickly when I don't even know that we know where it lives.
I agree. I think there's something practical that we can do to see if there's enough convergence in the way that we're thinking, and try some things out pretty informally. And if it works, that might be something that HL7 wants to take up over time. And frankly, that's how we did the original Smart Spec. We developed it totally outside of the standards world, got implementation, and then turned it into a standards project.
Yep, I think that's a good way to start. So I all I can say is I'm happy to sign us up, for some specific use case that we try to implement, and we kind of we can define the use case, and then we'll go implement something. Other people can go implement something, and then we can say, compare notes and see what we found useful and hard, and whether or not it has some legs. So I think that's it sounds a little bit disorganized, but it's probably a good organic way to get started.
And for use cases, I think we as a vendor of FHIR servers know a lot of real use cases which we want to implement. Starting from access up to the practitioner who wants to see only our records and stuff like this. So let's formulate this and try to iterate and to see some implementation and maybe pick the best parts of these solutions and try to compose some Frankenstein.
I think if we could formulate it in a way where we say, okay, here is one use case. Let's say it's like an expanded patient or an expanded practitioner compartment. Maybe we have a couple of them. Right? We're saying we're going to work on this compartment concept, and here's two real world examples of what these compartments could look like. Then we try to write some form of this is how we would describe this, whether it's some JSON document or something. And there was with this information in hand, could we actually go implement something on a server that makes this work? Or do we need to go back and add some additional information for it, and then we'll iterate, and then, that would be a good start. So I'm up for that.
Maybe find another name on the compartment, because
maybe
from the
if we use the word
compartment, and
when we started talking about
a lot, so probably let's give it another name, so it's not so guys not so worried about this.
Yeah.
How about a permission
me,
policy?
Let's not give it a we only have 5 minutes.
We're kind of working on that. That's all. I thought maybe that would be a good place to get the use case started.
Yeah, when we started working on this internally, we called them slices, data slices as a server. But that turns out that's a very loaded word too.
And I'm looking from the API perspective, and for me, it's like API, for example, the API definition.
Yep.
Maybe somebody can help me maybe understand this better. But when I think about compartments, I think about resources that are related to that compartment anchor, right? The owner of that compartment. But I don't look at compartments as they relate to the entity or client making the request.
No, so that I think that's a piece that's important, right? That you have to have a mechanism for when a token comes in, how do you establish the anchor? Given the token, how do you identify the anchor? And that becomes, this is where this thing, where I think you have a good point, Nikolai, with the being pure to the REST thing, right? You could say, if two clients go to the same endpoint, but they actually see different resources given the same search. I search for patient's name or observations from this date, and another client does it, they see different resources. That a REST violation. I don't think it is if you consider the token part of the of that. That token establishes the anchor and is part of the request. Something like that.
Yeah, I agree with that.
And we have a very nice tool like redirect in HTTP. And for example, when you said about advices, yes, Matthew. So I was thinking that sometimes the client can request search operation, but the access policy can rewrite and send the redirect for the with the properly. I mean, for the secure search options.
Well, yeah. I mean, as an example, the way like our system is working, I could send a request with a particular filter query parameter, and I may not have access to whatever data is behind that query parameter. So it's going to be rewritten behind the scenes, and I'm never going to know that I can't see it. So as sort of part of that security model,
to make it explicit, so the server can send the redirect with explicitly rewrite the parameters, and client can decide does he want to follow redirect or not, or maybe remember this advice in the future. So then the like my patient endpoint can work like a redirecting endpoint.
Yeah.
Yeah, I can see that.
So, I mean, one very pragmatic question is, where do we continue this discussion? Is it on Zulip in the security and privacy channel? Should we make a channel for this specific idea? What do folks think?
I think probably until guys say us go out, so we can stay in security and for chat. Yeah.
I don't think you'll get kicked out.
Well, maybe if we start being the majority of traffic, we can reevaluate.
Yeah. Okay. Yeah, I have to be honest that I'm not the best at Zulip. I have a lot of chat channels coming in, but I will do my best to monitor this. So it's just if I'm a little slow, that's my excuse.
I'll make a bot to mention you all the time.
Yeah.
Josh, do you know can the one stream of Zulip be integrated with WhatsApp or Telegram? So yeah.
You can write a bot to do that on the Zulip side. WhatsApp does not have much of an API surface area unless you join their business program, which is quite opaque.
Yeah. Like everything else in WhatsApp, it's part of the model. Yeah. Cool.
It actually works.
No, it's awesome. I use it. There's no criticism here, but it is a little bit of a black box. Okay. Yeah. So the thing that I can commit us to is that if there is some use case or okay, let's go and do this thing, it would be like an extended virtual connect-a-thon or something where we try to implement a specific use case. I can sign us up for that. And we'd be happy to participate. And it would be much. We have. I think all of these ideas have so much overlap that if we snap to one model or the other, it wouldn't make any difference to us. But we would rather implement something that there's consensus around than rolling our own and then having these policies and artifacts that are no longer shareable between implementations. If we can come up with something that's shareable between implementations, be much preferable.
Sounds great.
Awesome.
Well,
any final words, Josh?
No, this was great. I'm thrilled with the turnout and the discussion and the presentations. Thank you to everyone for joining and sticking with us for 3 hours. 1 hour in, I was like, I'm definitely going to have a break. We're all going to take 10 minutes off and come back. And then I apologize. It then totally slipped my mind because I was paying too much attention to all this discussion. But thank you. Everyone go take a break, go to sleep or wake up or whatever it's time for you to do now. Pavel, thank you so much for putting this all together. Nikolai, thank you for hosting this with me. Cheers, everyone.
Yeah.
Thank you. Bye.
Bye.
Hey, thank you.